Ready in a minute, okay. Just a small issue. Let me just start doing the talk. It's only pictures anyway, right? My name is Richard Campbell. I come from Vancouver, British Columbia. Not my first time in Copenhagen, and like you said, I've done many NDCs. This particular talk has emerged over time because there's been so much confusion around what's happening with artificial intelligence. I think the problem is mainly that it's a terrible name. It's an old term. It's from the 1950s. It was coined by a group of scientists that were trying to raise money from the US military, which they succeeded in doing. Now, this is in the 50s, so this is even before true electronic computers, like ICs and integrated circuits, all that sort of thing. These were electromechanical computers. But even then, there was a belief that we could actually do some computing performance that was sophisticated enough that it would make a difference for folks. Hey, that's my screen. How about that? That's the slide. Anyway, for a moment, they succeeded in writing some software, some provisioning and organizational software for the US military, and it did its job. The US military is still one of the most effective forces projecting anywhere in the world, and that's in the 50s. Then the money dries up. And when it does, then we go into the first of what we called an AI winter. And there's been a number of these over the years with different technology. Over and over again, scientists have used these terms to finance new technologies to experiment with. In the 1960s, there was a fellow named Joseph Weizenbaum who wrote a piece of software on a mainframe computer called ELIZA. And ELIZA he called a Rogerian therapist, which was a stretch. Now, Weizenbaum's goal was to show how effective simple software was at providing language responses to people that they reacted to. And literally, the Rogerian therapist idea was you would complain about something like how bad your lunch was, and it would repeat back to you. So tell me how bad your lunch was. And he had intended to just demonstrate that it was kind of silliness and like people are vulnerable to these sorts of things. And then his secretary refused to stop using it. And he found out people were putting hours into this software. Like just this sense that the software was listening to you was a big deal. That was the 60s. Like we're very susceptible to these problems. Humans are kind of hardwired to perceive intelligence in other places. It's a competitive advantage. You know, when we were pre-technology society out on the veldt, you know, our ability to project intelligence into our prey let us anticipate its behavior so we could kill it and eat it. There's also another human response, pareidolia. Pareidolia is the ability to see faces quickly. And again, imagine that in a pre-technology society. If you're the first one to perceive the face of the lion, you get to go running first, which means the other guys get eaten, and you get to live and propagate your species. And so that trait evolved in. You think of all the products we make today that have faces on them intentionally. We see them everywhere. Because there's really no downside to seeing the face, and the upside was really strong once upon a time. And so you think about the way we react to a car with the shape of its headlights and grille and so forth as a face. And I bring this up just to say there's a group of folks out there that are leveraging normal human tendency to create a perception around these products that isn't true. Now, the word artificial intelligence only comes to the public for the first time. It was coined in the 50s, but it comes to the public in a movie. The movie's 2001: A Space Odyssey. That's 1968, Stanley Kubrick. And if you haven't seen it, I recommend it, although it is very long. But in the movie, there's a computer, and the computer's name is Hal, and then Hal tries to kill everybody, like every other science fiction movie with artificial intelligence in it. Over and over again. In the 1980s, it's the Terminator movies. And in the 2010s, it's Ultron. I ask students what they think of artificial intelligence, and they say it's Jarvis. So the science fiction has penetrated their minds, and they believe they know what this tech is because they've seen it in a movie. And that's a problem, right? That's really, we've been deceived. We're misusing a name, and we've been using it literally for decades, and now we're dealing with the consequences of it. So this current wave, and I would, depending on how you count, it's the fourth or fifth wave of a set of technologies our branding as artificial intelligence, we generally would call it generative AI now. It comes from a group of people, but one of the key ones there is a guy named Geoffrey Hinton, and you've seen him on the news or in TV. He was a scientist, professor out of the UK, but working in Canada in the University of Toronto. Got his PhD in artificial intelligence in the 1970s. And he was big into neural nets at that time. And in the 80s, actually was part of a team that built software that was able to do handwriting recognition for things like envelopes, addresses, and for checks. So the early neural nets did work, just in a limited scope. Certain kinds of handwriting with very specific rules around it, they were effective. And so what Hinton was proposing even in the 80s is that we could build deeper neural nets. Now this is just a visualization of that, but the idea that with many deep neurons with this concept of backpropagation, he was part of a paper on how they would tune these neural nets, but essentially ends with more research is needed, we need more compute to make this possible. And so the tech kind of sits on the shelf until the 2010s, when a group of his students dusted off to enter a competition. The competition is the ImageNet competition. So this was the beginning of the idea of, can we have computers identify the contents of images? Well, we take this for granted today. Our phones can just do this, but in 2010 they couldn't. It was impossible until it suddenly wasn't. So the ImageNet competition was 14 million labeled images, mostly stolen from social media, so thanks. And the idea being, we have a description of what's in this image, so now you write software to look at the image and recreate the description. Simple. And up into in the early stages of this competition, 40% was the best anyone had ever done, with some decision tree models and things like this. But it was Hinton with his students, Ilya Siskovar and Kaparthe, a few different folks, all names you know, took this old technology, applied it to modern GPUs, entered the competition in 2012 and got 75% right the first time. And within 2 years, 100%. And it was a solved problem. By 2015, you could expect you could take a picture with your phone would tell you what was in the image. It's astonishing. And we already take it for granted. It's not a big deal. Now, that's not the only place where this new generation of technology emerged. Over on the West Coast, at Stanford Research Institute, they were experimenting with voice. So there have been voice recognition systems for years, but they were bad. It took a lot of training time. 80%, 85% was the best you were going to get. So the SRI folks sat down and took a whole lot of recorded audio, passed it through this generative model until they could do really effective, like 99% voice recognition with it. And they made it into an iPhone app and put it on the store, and Apple was so impressed by it, they bought it, added an I to the name, and called it Siri. So this was almost a simultaneous exposure. Like the ImageNet thing, Siri, all happened roughly in the same time span. Now, back on the East Coast, University of Toronto, Hinton and his cohort are encouraged by Google to form a company to commercialize the technology they developed for image recognition. And as soon as they form that company, Google buys it. Shocking. And brings all those folks down to Menlo Park, the Silicon Valley, to join a group called Google Brain. And so Google Brain had, for a few years, been rounding up kind of the best minds in this space of generative AI, to the point where other organizations were getting really nervous about it. And back when we weren't quite as annoyed with tech billionaires as we are today, a bunch of tech billionaires sort of showed up saying, hey, we're really worried about what Google's working on in private. We think they should do it out in public. And this was folks like Sam Altman and Elon Musk and Peter Thiel and Reid Hoffman. And they set up another company in 2015 called OpenAI. And OpenAI's mission publicly was to do AI in public, was to make sure it was visible. Privately, it was recruit those scientists out of Google. And that's what they did. Siskovar goes over there in 2016, they poached them all. And the OpenAI guys, they were supposed to be well-funded. After all, it was run sort of by a bunch of billionaires. It just wasn't well-funded. You know, Elon for many years was saying he put $100 million into OpenAI. Turned out it was $16 million in 8 Teslas. Okay. But they do get a remarkable set of talent together. Enough that Elon's so impressed that by 2018, he tries to take over the company, gets kicked out of it. And he's still angry about that. You're watching the lawsuits still go on to this day around that. The first product that the OpenAI guys work on is a universal translator. So they're trying to build the Babel fish from Hitchhiker's Guide. And it more or less worked. It was the tokenization strategy, this technique for taking words, breaking them into numbers where one word would represent by multiple numbers. Some cases, multiple words could be represented by a single number. But by tokenizing language, you could then detokenize it into other languages. But along the way, as they worked on the training set against text on the internet, they found they could create a response engine that, with some training, they ended up with this thing they call a generative pre-trained transformer. Now, in that same time space, as image recognition got bigger, they started using image recognition in healthcare for working with MRI imaging, X-rays, and so forth. And in fact, our friend Jeff Hinton here in 2016 announced to the world that he thought radiology was a dead career, that the computers would do it all. Because that now had, at this point, there's like 700 models certified by the FDA to do medical image recognition. The reality was he was wildly wrong. The opposite actually happened. The demand for radiologists has gone through the roof because the demand for medical imaging only grew. Back when it took 6 weeks to get an image analyzed by a radiologist, a lot of doctors just wouldn't bother requesting an image in the first place. You want to do your diagnosis faster than that for your patients, so you don't want to wait. But as the software came into play and the radiologists could work faster, the demand for medical imaging outran the systems. So even though radiologists are working wildly faster with better technology, they're still falling behind. So we're only growing the number of radiologists, but that takes time. So once again, we see automation opening the door to far more productivity, and that increases demand. So the opposite goes on with this mechanism. Meantime, over at OpenAI, they are building this GPT. The first version they put out in public is in 2019, GPT-2. And they make a variety of models for it, the smallest being about 120 million parameters, and the largest 1.5 billion parameters. They make different sizes because they're so strapped for cash, they can't afford to run their own GPTs. And so they make smaller models to do testing with. They only run the big model when they're really sure they need it. This is also the point where OpenAI sort of backs off on their original deal, where it's like, hey, we're going to do all this in public. They're like, wow, this is really quite a powerful tool, and we're concerned about what people would do with it, so we're not going to publish the source code. Sorry about that. And so the business evolves. And it was around this time that Microsoft shows up. And this is actually Kevin Scott. He was the former CTO of LinkedIn, and he knew the folks at OpenAI. He'd worked in Silicon Valley for a long time. Now he's working for Microsoft because Microsoft acquired LinkedIn. And his job was to find workloads for Azure. He was at the office of CTO, and Microsoft had gone all in on Azure, and so they were just trying to find as much business as they could. And in a now fairly famous email in 2020, Kevin Scott writes to Satya Nadella and says, hey, we've got our own experiments in AI. I think the OpenAI guys are ahead of us, and they're strapped for cash. I think we should invest in them and move all their workloads to Azure, which is what you wanted me to do anyway. And so with some encouragement, OpenAI restructures their company to allow for investment, and Microsoft kicks them $1 billion in exchange for they spend all that money on Azure, which is a pretty good deal for Microsoft if you think about it. I just made $1 billion investment and made $1 billion in sales. I made $1 billion into $2 billion. But it definitely helps OpenAI. That accelerates their ability to do more development. And in the midst of this, they publish a paper called the Neural Scaling Laws. This is in 2020, where they go against everything we really know about machine learning. For a long time in machine learning, the previous decade or two, there was this very standard set of practices around restricting your training set, not overtraining on that training set. They called it overfitting. If you train too hard on the training set, it's only good on the training set, it's not good on anything else. But the Neural Scaling Laws paper said this: train on everything, and then it'll do everything. And as long as we keep getting the set bigger, at some point, it'll be perfect. This paper is kind of the excuse that the hyperscalers have used more or less ever since for the approach to the generative AI systems we're seeing in LLMs. So that $1 billion turns into GPT-3. This is during the pandemic, so it's hard to remember what was going on then. We're all fairly distracted. In 2020, Microsoft kicked another $2 billion into the company, and they produced this first version of GPT-3, up to 175 billion parameters. So the largest GPT-2 was 1.5 billion, so this is literally 100-fold bigger because they've got money and Azure. They were publishing PR pieces about this, the 5th largest supercomputer in the world to build this model, 285,000 CPUs involved over several months of training. Still wasn't that good. Human languages are complicated and they're irregular, and it's difficult for the model to make really good responses. But also down in the Silicon Valley was GitHub, and GitHub said, hey, what if we restricted the set? What if we used programming languages instead of human languages? And that had some better results. That's the first product called Copilot, because you know it's a good name, right? Because that means you're the pilot. It's still your fault. But also, and there's no way Microsoft would have thought of that name. Microsoft doesn't think a game's that good. They know how to ruin a good name, though. And so this is largely the first product on the LLM space is GitHub Copilot. Meantime, back at OpenAI, they're trying to make the language system work better. And they realized they need to do a second-order training. This was a clever innovation. And that second-order training was to use the existing model with humans, where you'd make a query, ask for a piece of information, the model would return 3 or 4 answers, and then you'd rank those answers. And that would build up a model to tune their responses. And they typically did this in developing parts of the world where the people were inexpensive, Indonesia, Philippines, that sort of thing. But by the fall of 2022, they've run out of money again. And so they come up with this great idea. Let's just do it in public. Instead of paying people to do this, we'll just make a public interface to it so everybody can experiment it, and we'll evaluate the data to further train the model. That's ChatGPT. It was meant as an experiment. It was not meant to be a big product. It was just an experiment, a way to get people to do training for them because they were strapped for cash. What they didn't expect is that 100 million people would sign up for it in the next 2 months by January of 23. And that was the fastest that any product had ever gotten to 100 million users before. The previous fastest had been TikTok in 9 months. Now, I know a few of the folks that were working at Azure when that 2 months went on, and they had a really lousy Christmas because scaling to 100 million users is not easy. That's a lot of resources they had to scramble to put together and to spread around the world as people signed up in droves. I had a chance to talk to one of the folks behind the system, and I said, like, why do you think 100 million people signed up in 2 months? And he's like, well, you know, we kind of did it over Christmas, and people would rather talk to software than their loved ones, so. Like, get a dog. Why are you talking to software? That's just weird. And I hope you notice I'm being very careful with language here. I'm fighting against anthropomorphizing the software, right? I'm not going to refer to it as a person because it's not a person. And I encourage you to pick up the habit too, to help others think clearly about the fact that this is simply software. It's clever software, but software nonetheless. And it's between science fiction and bad naming, we're having a tough time remembering this is software. 100 million users. Satya Nadella, who at this point has been CEO for 9 years, in 2023, for the first time ever does a Bill Gates letter internally. He says, all right, here are the OpenAI APIs. We have access to them. Every team needs to build something with their product against these APIs. Go forth and make way too many copilots, which they will do. And we've only seen a few, and it's still too many. There are many, many copilots now being built. And this is a point, in hindsight, we recognize is a technological trigger. So I'm going to pull out the Gartner hype cycle here, which we came up with after the dot-com boom, and talk about this cycle that some technology goes through. Sometimes you have a technological event that brings all the investors to the yard, and a stupid amount of money shows up, and stupid money makes stupid decisions. And so with that much money flowing in and that many companies being formed, you have to keep making bigger and bigger promises to your investors until you create a hype cycle so vast you get to this peak of overinflated expectations that's insane. And when those expectations can't be met, then the investment comes flying back out again, hopefully not losing too much money along the way, at least for the investors. A bunch of companies fail, and we bottom out and then climb back out. So this happened between 1997 and 2001 for the World Wide Web. the technological trigger at that time was the IPO of Netscape, the first time a pure digital company IPO'd. I mean, even in 1997, Microsoft still shipped CDs for all of their software. And every update was expensive because you had to ship out new CDs. But here was Netscape, a company that had no physical media of any kind. You downloaded the browser, you got updates from the internet. It was a profound impact on investors, this zero marginal cost company, and they poured money into anybody who could say they were internet companies. And we inflated expectations until we thought pets.com was a good idea. And then the money came back out. And the internet didn't go away. The World Wide Web survived. A lot of dumbs subsided. We're in another one of those. Doesn't happen every time. It's not the only technological revolution we've had since the dot-com boom, right? One would argue the mobile was a huge revolution, changed the way we interact with computing in general. We sell far more smartphones than PCs by a mile. One would argue that the cloud is a revolution as well. But neither of them went through a hype cycle. A hype cycle has to have certain elements distinct to it. It helps that the investor doesn't understand what they're investing in, so you can tell them stories. And AI fits that category brilliantly. And that you can set expectations that are insane. You can say every job will be replaced in the next 2 years, and people don't just laugh at you. Instead, they give you money, which seems like a really dumb thing to do. So here we are in another one of these cycles. Now, Microsoft gets there first. They kick in another $10 billion to OpenAI, so that's up to $13 billion if you're keeping track. First product out of the gate is Bing. Now, the reason they were quick here is because of Project Sydney. They already had been working on a natural language interface to their search engine to try and make it relevant. Now, this was a much better natural language search interface, and both guys who tried it thought it was really good. So, turns out you can't save Bing with a better interface. But with that $10 billion, in another year or so, OpenAI makes an even bigger model. March 23, releasing GPT-4. So now we're up to 1 trillion parameters. So 1.5 billion for 2, 175 billion for 3, trillion for 4. Not quite a doubling, or maybe a 5-6 times increase. But at that point, we've pretty much indexed all of the internet, including 4chan. You know, we're not going to make a 2 trillion parameter model. There's no more data. So we're, in a lot of ways, you could say, in hindsight, certainly, we kind of peaked at this point. It's an exciting time. We're impressed with the capabilities of it. It's still got lots of tuning to go. We're going to make some revisions on it, but we made the big model. It's hugely computationally expensive. Microsoft starts pouring out the Copilots, M365 Copilot being big one. They're not sure what to make here, so they keep making different versions of it, to the point where, you know, there are a couple of good Copilots. Like, if you ever played with the SRE Copilot, it's impressive. I think they call it the SRE agent, because even Microsoft people are trying to distance themselves from the Copilot name. It's just too many products, and many of them are bad, and so folks don't know what to use. 4.0 is when they went multimodal, so this is now not just text, but vision and audio. This is in 24, and around that same time, we get the first of the DeepSeek models. The West did their very best to ignore DeepSeek, but what DeepSeek, this is the Chinese model, and again, it's built against the other technologies that were created at the time. So they definitely took advantage of what had come before it. But the main thing that the Chinese model talked about was, you know, you don't have to be so big and still get pretty good results. It was sort of the first time we didn't just stick with the neural scaling laws and just keep getting bigger. And nobody liked that, so they ignored it. They did their very best to just move on past it. By 2025, we're starting to see real results in programming, software development especially. You know, there's been a lot of noise, a lot of excitement and hype, but not a lot of products. Now, I make a lot of podcasts, and I'm used to new technologies coming on the market. And many times I get in the same situation where I'm happy to talk about a new technology on the show when it's new. But I can do 1 or 2 of those shows about how cool it's going to be. After that, you have to show me. So pretty quickly with these LLMs, I hit a point where it's like, show me your product or I'm not doing the show. And there were no products for quite a while, till last year, till 25. 25 is when we started seeing real impacts on programming, starting to talk to the sort of best and brightest software developers that are taking advantage of these models to not just get hints for code, super IntelliSense, but to the point where they're actually wired into GitHub and are assigning issues to an agent model that can iterate on the code and produce the code results in a pull request. And then you can argue with the tool in the pull request to do further tuning before you accept it. And I've seen teams get extraordinary results with these tools. It's not easy. You're still hand-rolling a lot of stuff. It still can go badly wrong, but they were the first real results we saw anywhere. And it was part of the proof was just the sheer proliferation of product. Whenever you see this many different groups of people all try to publish software at the same time, roughly in the same space, you know it's an unsolved problem with some potential in it. Now, half these products already have disappeared. We're in a weird, crazy, frantic ecosystem time of making all these different things. So I couldn't even show you them all. And in some cases, some of these have disappeared because the big companies have come along and gutted them. Not bought them, that would be polite. No, just hired all of their staff away, then their senior leadership, and it's like gutted them effectively. I think we were just talking last year. In August of 25, we get GPT-5. And GPT-5 was a reminder that we just can't keep getting bigger. Right? It was kind of a flop of a version for the most part, but there were several different forces acting at the same time on GPT-5. And so we tapered off. It's like, okay, it's not just going to be radical improvement, radical improvement, radical improvement. It's a small increase in capabilities. One of the things they originally pitched in GPT-5 was that it was very literary, that you could ask it to write in any language style. You could ask for it to be written as Wordsworth or Shakespeare. Turned out it was terrible at that, actually. It was later sort of revealed that the way they actually trained up the model for doing the literary thing is by exercising against another GPT, and the fact that the sentences made no sense didn't bother the GPT at all. It thought the results were great and gave it all green lights. And then humans used it and went, wow, this isn't English. The tuning continues. Anthropic's now the new and shiny. They've really had the win lately. Their battle with the Department of Defense, or Department of War, Department of Defense, helped them publicly. They were trying to be the good guys. And their results with Claude are impressive. There's no two ways about it. From the dev side of things, using their agentic models, we're getting pretty good results. So they're the new and shiny at the moment. In the pundit space, we talk about, we're going back to the dot-com boom. Are these companies Netscape or are they Google? Because today, most people don't remember Netscape. They didn't survive the dot-com boom. They came out, they got acquired by AOL, which also didn't survive. But Google also started in that time span, and by 2004 had to IPO because they had so many shareholders and became the success you see today. So they came out of the dot-com boom, but they were one of the ones that went on. So we're looking at all these little companies and saying, well, which one of these are going to survive? Which one of them are going to be the next Google? And which of them are going to be just another Netscape? Don't know the answer to that right now. I think most people would pick Anthropic as the survivor at this particular moment, but wait a month. All these companies make a lot of promises. I'm told by most folks, wow, it's moving so fast. It's like there are people out there that are really incented to have you believe this is going quickly. And if you want to give yourself a break, do what I do, which is at the beginning of each month, I make notes about what all of these companies are promising, and then I compare them to the promises the next month. And let me tell you something, they're the same promises every month. They aren't progressing that quickly. What they've learned to do is fill the pipeline with noise, because that makes it feel like it's going quickly so that you won't think too much before you spend more money with them or invest with them further. None of these companies are profitable, not even close. The big tech giants aren't profitable in this line of business. They have other sources of money, so they're fine, but these companies are far from profitable. So they can't report to their investors profit. That's not an option for them. They have to report other things. They have to come up with metrics that keep their investors happy. So, in these agentic models, they talk about the interactions, like what pieces have to interplay with each other. They talk about a revision of software entirely, thinking, and there's a case here for how is software going to change? Does the SaaS model even make sense? When we've got tools that are really good at interacting with different data layers to pull data from it, are we really locked into our ERP systems anymore? How badly do I need a CRM these days when I can surf through emails to figure out who I've last contacted and what I should say to them next? There's lots of changes going on in all these spaces. So while we're coming through this cycle, and I think we're headed down the trough of disillusionment just fine, far from bottomed out, but on our way down, we're starting to think seriously about what does this really mean? What's the real value in all of this? You're seeing this with the price changes, right? That now these companies can't just keep hyping for the world. They have to start to show maybe we can get to profitability, decrease the free use, increase the paid use, increase the cost. But it also begs the question, like, well, is the hype cycle necessary? Because we've had new technologies come on the field recently. They didn't go through this. Why is this being hype cycled the same way the dot-com boom was hype cycled? And one of the things I find in parallel between the two, having lived through them both, is that a key part of what made the dot-com boom hype cycle work was expanding the infrastructure of the internet. It wasn't the part that people talked about, but a tremendous amount of money was spent on building out new data centers, undersea cables, and a lot of those companies lost a lot of money. At the end of the dot-com boom, most of those companies went broke. And that's why we ended up with like call centers in India, because the cables were cheap. They'd been bought up for 10 cents on the dollar. And here we are again in this big hype cycle. So I'm looking, well, what are we really spending money on? And we know what it is. We haven't talked a lot about it, but it's more and more in the center of people's minds. It's data centers. Now, there are the three big players, right? It's Amazon, Microsoft, Google. And Google even a distant third. Then you have tertiary players, the Metas and Apples and of the world. I won't even really talk about X, because goodness knows. One of the interesting truths about the data center situation was that previous to ChatGPT, even coming into the pandemic, it was getting really hard to build data centers. People don't like them. Municipalities don't like them. They don't employ very many people, take up a lot of space, they're kind of noisy, consume a lot of electricity, fair bit of water. And so if you look at the annual report for Microsoft in 2019, they include a section warning, hey, our demand for cloud is going up, but we can't keep up with our data center builds. We're struggling to find places we're allowed to build them. Because bit by bit, the municipalities are recognizing we have to put more controls around these things. And goodness knows the hyperscalers don't want controls, so they're always looking for other places they didn't want to put controls in place. And then the AI hype cycle hits. And all of a sudden, building data centers is very cool. And the hyperscalers dump astronomical billions into building data centers. The numbers are absolutely staggering year over year, to the point where they're literally distorting the U.S. economy. For the most part, since the new administration has come in, the U.S. economy has been declining. But the spend by the hyperscalers is in the hundreds of billions and literally has filled the gap, kept the stock markets up, so that it's hard to understand how badly they're actually doing. In 2024, more than half of the increase in value in the S&P 500 came from 7 companies, the Magnificent Seven. Today, they call it the Magnificent 10. 10 companies out of 500 representing almost half the value of the largest index in the world, the S&P 500. Now, that's 80% of the stock values in the US, but it's 50% of the stock values worldwide. And it's 10 companies. And they're all popped up for one reason. And when that reason doesn't make sense anymore, that's a pretty big hit for all of us. The other part of this is what Microsoft started with their investment in OpenAI. It's what we call self-dealing. NVIDIA is leading the charge on this right now. They've got a huge bank of cash, $5 trillion. You know, when you buy stock in NVIDIA, they get the money. And they have no way to use that much money. It takes too long to build more fabs. That's at least 5 years. You've got to put that money to work today. This is the Bloomberg diagram where they're showing that what NVIDIA is doing is taking investments of 100 million, 200 million, 500 million into these little AI companies. And the job of that AI company then is to take that money and buy NVIDIA chips with it. Not that they can deliver the chips, just make the order. Because then the $500 million investment is worth $500 million, and the $500 million order also worth $500 million. I just made $500 million into $1 billion. I'm a genius. It's one of those signs of you've overinvested. You have too much money in play. You can't build the things that we really need to build, but you have to keep the money working to keep the investors excited. And so we have these past curves of how a bubble bursts. where the overinvestment continues to a sort of peak point. That peak point, I think, is already hit. The peak point here, this new paradigm point, the reason it started going back down, let's see if my pointer will do its thing. There it is. What happened here in that peak point? I'm not going to play with that anymore. It was last fall when all of the memory companies, TSMC, Micron, all those guys said the same thing. We're not doubling production of RAM. It takes us 3 to 5 years to build a new fab. We don't think you guys are going to be around in 3 to 5 years. You know, you've been ordering up chips like crazy. The game that's being played on the data center side is that they're using third parties to buy up land. And as soon as they get the land and an agreement to use it, then they make the request for the power, and they order up the concrete and stuff to build the building, and they order all the computers. And they're doing it the same way you would buy Taylor Swift tickets. You open 10 browsers to get 1 pair of tickets. So they're ordering far more than they possibly need on the chance they're going to get to build any of it. There's now organizations out there going around checking these sites to see, is any construction going on at all? And to be sure, there is some. In some cases, there's none. In some cases, there's like a girder put up, so you can call it underway. But they're overbuilding, and they're over-ordering. And the memory companies said in last year, yeah, we think you're over-ordering and you're not going to be around here, so we're not building that many chips. And at that moment, the lies put to paid. The projection you made about how much compute you're going to need in the next 10 years cannot be delivered on. There isn't enough RAM, and there's not going to be. And you saw for the first quarter this year, all the tech giants' values go down a bit. So, and if you go look at where the trades were, it was all the institutional investors, the big pension funds and things. They're not running for the hills, they're just backing out a little. They're deleveraging. And that's that first curve down. And it hits that loop right around April, when we start hyping data centers in space. And so we've slowed the decline again while we try and figure out if that makes any sense. And if you want to get my opinion on data centers in space, I'll do that this afternoon in room 1. Is this really as bad as the dot-com boom? Well, let me show you another graph. So this is a graph of overall PE ratios. So this is price to earnings ratios. And price to earnings is way out of whack right now, but it's not as out of whack as it was in 2000. But it's the second highest it's ever been. So only the dot-com boom where price earnings is wildly out of whack as they are right now. I don't know if that's the same or not. It sure seems like the same. And that the prospect of the decline is serious. Like, that's going to have impact. There's no two ways about it. The other impact is on people. So let's talk about what's being done with the software that's harmful. We call it ChatGPT psychosis. Look, if you're in tech, maybe you're less vulnerable to all this, but let's look at this guy. Does he look like a tech bro? That's because he is a tech bro. This is Jeff Lewis. He's one of the partners at Bedrock Investments. They invested in OpenAI and Vercel and a bunch of others. You may have seen him in the news because he's been spending entirely too much time with a chatbot and got himself into a psychotic episode where he put out videos about how a non-governmental system, not visible but operational, has targeted him. Now, he's getting help, and I'm glad. You know, nobody deserves to be mentally ill. But it's serious. It's dangerous. It's cost lives. People have killed leveraging ChatGPT and been killed. And the tech companies know it. One of the aspects of GPT-5 that helped it flop was that they dialed back the obsequiousness. You know, this software is designed to maximize engagement. And the way it maximizes engagement is by always being positive reinforcement, always being syncopatic. Like, you're really onto something now, and you're really thinking now, and that's an awesome idea. Let's run with that. I've got more to do. So that you'll keep using the tool, because the metric they take to the investors is user engagement. Because they can't show profit, there isn't any. They can't show results, because there's hardly any. So they use engagement to the point where people are dying. And so they dialed it back in GPT-5. They also tried to shut down all the other models, only use GPT-5. It's more efficient, it's more advanced, and people didn't like it. And one of the reasons is because it wasn't obsequious enough. They wanted their buddy. And so Altman gave in, turned 4.0 back on, and you got these posts. My baby is back, and I'm crying. And I don't care. I don't care if you think I need help, because my baby's back. It's terrifying. It's also maybe a brief period of time. This represents huge liability to these companies, so they're going to need to deal with this one way or the other. But also, the population gets educated. This is not your friend. It's also not your therapist. Go touch some grass. Put down the software. Remind yourself that it is software, right? It's the price of the deception to do the fundraising. We call it artificial intelligence. We lean into the science fiction, so you'll give us more money. Who cares who dies? We'll fix it. We have to. There's really no choice about all of that. I'm also not particularly worried about generalized intelligence or superintelligence. Again, it's been a marketing engine. They've literally leveraged this at OpenAI. The chant internally is AGI, 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 because that's how they recruit scientists. With no real evidence that the technology can ever deliver. Actually, there's pretty good examples that it can't. The fact that on average, people who get more knowledge about this tool believe in it less, trust it less, is a pretty good sign. The folks that are most excited about this are the ones who know the least about it. If you really want to dig in deeply, there are great books in this space. I like Roy Blatt's book. It's a hard read. It's worthy. I read a chapter, and I'd have to sit and think for a couple of hours, because he really encouraged me to think about what intelligence actually is, what sentience looks like what it would possibly mean to have real intelligence. We press against this all the time with these tools, right? The current one is the car wash scenario. Hey, I got to get my car washed today, and the car wash is only 50 meters down the road. Should I walk or drive? Because the software has no, quote, common sense. So it's going to go 50 meters, just walk it, leaving out the part where you need the car to wash it. And then there's the deepfakes. And I don't know if we're going to get audio for this, but you've probably seen this one. This is the original deepfake from 2017, right? It was done at the University of Washington, and it's an Obama animation. It's being voiced over by Jordan Peele, and it's very funny. It's also almost 10 years old. And I'm less worried about deepfakes today than I am in the past, mostly because people have gotten way more skeptical than they were in 2017. It's way easier to make them. There was a guy on Twitter who was, I'm waiting for Donald Trump to be arrested. Meantime, here's some animations of him being arrested. Because he no longer needed a group of scientists and months to generate the thing. It was a tool you could run off of the back of Twitter. These are powerful tools. They can do inappropriate things. There's a case for better regulation about what's acceptable and what's not. I think for better or worse, the EU is leading in this space with their current round of regulations. I hope there'll be more enforcement. I think that's the struggle we have right now. And I encourage all of us in this industry with our skepticism to make yourself available when you have an opportunity to work with politicians. Call your MP, encourage them to make good choices, and be a knowledge source. We're the experts, for better or worse. To be clear, nobody has 10 years experience with LLMs. They've only been around for 3. So we're all starting out, but most of us know more about this than the average person does. And we choose what happens with these technologies. We've made evil technology before. Anybody remember Grayball, Uber? This came and went. So Uber subverted the taxi industry. And to be clear, the taxi industry deserved to be subverted to some degree, right? It's its own kind of monopoly. And so here, running off a phone with a regular car, you could sign up, you could drive people around. It's not safe, it's not wise. They also got overinvested. They got $60 billion. Nobody makes good choices with $60 billion. And as they were struggling to get into circuit markets because they are well protected, they wrote this little nugget of software, it's Grayball. And what Grayball did was it had a list of all of the regulators' phones. And so when a regulator would pull up Uber, there'd be no cars available. So it wasn't a threat. When regular people pull it up, sure, the cars were fine, they could use it. And they kept that going for several years so that regulators didn't think it was significant and just allowed Uber to exist until it was everywhere. Until finally one of the developers leaked it to the press. And it got pulled off the store briefly, and Clinic got in trouble, but it all got cleaned up eventually, and it went away. I mean, it's not the only scenario like that. Again, we're putting it behind us, but what Cambridge Analytica did for Brexit is a horror show, where they exploited the data in Facebook to lie to people really effectively. Right? Back when it was hard to tell that if you tailored an ad to an individual on Facebook, that individual could not tell that they were the only one seeing that ad. And they used that to help people make bad choices. This is what software can do. It's always been a risk. And these new tools represent an even larger risk. And some folks say, like, maybe we should just back away from it, not go here. It's not worth it. And I disagree. I think the tech is valuable. It has to be well used. And I want to give you the best scenario, the one that for regular mortals even, I can make an explanation where it's like, you can't back away from this. It's done too much good. So let's talk about DeepMind. So this is Demis Hassabis. He was out of the UK for a long time. DeepMind got acquired by Google. He refused to move to Silicon Valley, which I think helped him. Kept his team there. It also was a pandemic, so he had an excuse to stay in place. And if you remember, his original product was playing video games. So he was building a machine learning model that could play video games. And it figured out breakout first, where it learned to cut out the side and then get the ball in behind. Like, it was clever. It was kind of cool. It was video games, so it wasn't important in any way. But he decided to aim himself at a more difficult game, to aim at Go. And Go was always a game we thought software could never play. Too many combinations, impossible to play. So AlphaGo was trained over several years against all the best games ever played in the world until finally it produced a player better than a human. And that was a sort of profound moment. Again, it's just a game. He didn't stop there. They went on with AlphaZero. AlphaZero is now an adversarial model where you take two entities, two agents, with the rules of the game. They just play against each other until they build up their own play style that could beat the original AlphaGo. And it didn't play like a person at all. AlphaGo was just the most optimized way that people could play. AlphaZero was a different beast entirely. Still just a game. So then he targeted protein folding. And if you're in biology, you know there are 20 amino acids that are relevant in this equation, and they assemble into different ways to create a variety of proteins. And as those different aminos bind together, they twist up, they fold. And protein folding is one of these insanely complicated things in biology that we're still just figuring out. John Crenshaw was the first scientist to actually work out the protein folds for a single protein set, the myoglobin set. He got a Nobel Prize for it. It took him a decade. And over the past 60 years or so, tens of thousands of biologists using various techniques like X-ray crystallography have worked out roughly the assemblies of about 150 different protein sets. Every one of them leads to new medicines, new understandings, the way the body works, could save lives. The problem is if you take all the different proteins and all the different ways they fit together, it's 10 to the 35 possible combinations, and that's a lot. So we've made games. There's a competition called CASP to work out if you can figure out different protein foldings. And over the 20 years or so that contest has been going on, there wasn't a lot of results. It was really hard to build software in this space. In the middle aughts, there was actually a game for people called Fold It, where you could do experiments and then measure them against the actual result sets on different proteins. And a group of gamers over a period of 2 years actually worked out a protein, the aflatoxin protein, which is cool, won. So Hassabis and his team aim at protein folding. Over about 4 years, by 2020, they were at 90% accuracy. By 2022, they were pretty much dead on. They now knew how to, you could give them any protein set and they could work out the protein folds for it. What did he do with it? He computed the 200 million most common protein fold sets possibly needed and published them for free. And changed medicine, fundamentally. The new treatment that we have for leukemia comes from that. There's a new malaria vaccine comes from that. There's 3 new antibiotics that have come from that. Fundamentally changed medicine. It will take us decades to even know everything that we've gotten from this data set. This was only possible with this adversarial training model of generative AI. It's extraordinary. It's made a huge difference in the world to the point where we're just even struggling to comprehend what we've just done. We choose what we do with these tools. It's entirely up to us. We have a lot of choices here on where we take these tools from here. Get back to the fundamentals. Focus on the things that are important. This is not the first time we've been disrupted as an industry. It's happened over and over again. It's also wrapped in a hype cycle, which makes it harder. You get back to the fundamentals of what you care about. Our job was never to write code. It was to solve people's problems. They couldn't code their way out of the protein folding problem, so instead they built a model that solved it. Maybe that's the answer to the problem you're dealing with. I don't know. What I do know is that every time we get disrupted like this, we go back to the things that are the most important, we make good choices, and we get great results, and we can help people. It's a crazy time, I admit it, but it will pass, and we'll be back to work. The work will look different. That'll be okay. We'll still make a difference. Thank you for spending your time with me.